Hello, this is Mario from Audion. In this video, we will talk about the Room Acoustics Parameter List. The Room Acoustics Parameter List allows you to enable, disable, and edit the room acoustic parameters that will be shown in the results. In Audition's Auditorium and Combined, you can even define your own parameters. You can access the Room Acoustics Parameter List by clicking this icon. You will see two tables. The top table will list the frequency-dependent parameters, while the bottom table will list the wideband parameters. This window will work slightly different depending on your Audion edition. In Audition's Basics and Industrial, you will make your changes directly here. In Audition's Auditorium and Combined, you will first need to expand the tables to be able to edit your parameters. To do that, you click on this icon. An additional table for energy intervals appears at the top left, but I will talk about that later in this video. The Type column shows the parameter type. The Visible column is where you can enable or disable parameters from showing in your results. You can enable parameters that you're interested in, and disabling parameters is useful for reducing bloat. That is, it reduces having to scroll through many parameters, especially if many of them are not of interest. As an example, here I will disable the SPL parameter. The settings are saved automatically when you close the window. Here, we can see that the SPL parameter is not shown in the Energy Parameters list. And when scrolling through parameters in the Energy Parameter Bars tab, it skips from Center Time to G. You will experience the same thing in the Grid Response. If you wish to toggle many parameters, the easiest way to do it is by clicking on the Visible column, then alternating the down arrow and spacebar. In the Decimals column, you can specify how many decimals are shown for that parameter. You can double-click on cells to edit them. However, depending on your Audion edition, some columns may not be able to be edited, which I will explain later in this video. The Y origin checkmark is to force the axis of the parameter to start at 0 in certain graphs, such as the bar graphs. This is typically the case for parameters that are not measured in decibels. Remember that decibels go down to -infinity, so this is disabled by default for parameters measured in decibels. Also, this does not affect color scales in grid responses. This is because, in grid responses, the parameter axis is instead adjusted by percentile ranges, which we explained in our video on color grids. In the Unit column, you specify the unit shown for each parameter. The Manual Grid checkbox is to manually define the parameter's value range in grid responses, instead of the automatic adjustment by percentiles we mentioned earlier. When you tick the checkbox, you can enter minimum and maximum values here. You will be unable to enter a minimum larger than the maximum or a maximum smaller than the minimum. If you run into this situation, simply adjust the other number first. The Color Scale column is to select which colors are used in displays such as the grid response. If the selection is blank, this just means Audion will instead use the current default color scale, which is set up in the Options menu, Program Setup, Grid Settings. After you select a color scale, click anywhere else to preview the colors. The end colors column specifies the number of fixed colors in the color scale. The first number that appears is the number of colors manually defined in the color scale. You can change this number, and Odin will redistribute the colors across the specified number of colors. In this case, however, this won't make much of a difference, since Odin still interpolates in between the colors to display a smooth and gradual color scale. You can untick smooth colors to disable the interpolation, and then the number of colors has a much more noticeable effect. When smooth colors is disabled and only a few colors are used, the grid response looks more like a contour plot. STI parameters are defined this way by default, so that the different colors correspond to the different descriptive qualities of speech intelligibility. If you want to define your own color scales, we have a separate video tutorial that explains it. In the JND column, you specify what is the just noticeable difference for that parameter. And the next column specifies whether that difference is in percentage or units. If it's enabled, then this number is taken as a percentual difference. If this is disabled, then this number is taken as an absolute difference in the parameter's units. The JND is used to express the difference between simulated results and measurement results in places like the multipoint response or the genetic material optimizer, which we explained in another video. The measured column specifies whether the parameter will be shown in measurement results. And this require calibration column specifies whether a calibration file will be required to display that parameter in measurement results. Finally, we have the description column, which shows a short description of the parameter. Of these columns, some can be modified only in certain Odion editions. The visible, decimals, Y-origin, and measured columns can be edited in all editions. If you have Odion Basics, then these are the only columns you can modify. The columns related to color grids are available in any edition other than Basics. And the rest of the columns can only be modified in Editions Auditorium and Combined. From here on forward, I will talk about features exclusive to Editions Auditorium and Combined. In those editions, you can edit the formulas of parameters or define your own parameters. Before I show how to do that, I will explain energy intervals, since that's one of the variables you can use in the formulas. For each point response, Odion calculates a decay curve, and acoustic parameters are calculated from different intervals of the decay curve. Here, we have a few defined energy intervals for omnidirectional receptors, with the intervals defined with start and stop times in milliseconds. E-omni total is defined between 0 and infinity, so it gives the total energy. However, E-omni 50 is defined from 0 to 50 milliseconds. So, for example, this would be the early energy in a calculation of Clarity 50. You can create a new energy interval by clicking this icon. Initially, this creates a copy of the currently selected energy interval. However, you can edit it as you wish. For example, I could define an early energy interval up to 60 milliseconds. You can also define energy intervals for figure of 8 receptors. The explanation for each of these receptors is found in the context-sensitive help, which you can access by pressing F1. When you select a parameter, some of them will display their formula beneath the table. For example, here we can see the formula for Clarity 50. The late energy is defined as the total energy minus the energy up to 50 milliseconds. So here we have the early energy divided by the late energy. Finally, this is converted to decibels. Let's create a new parameter. Again, you click on this button, which is the same button we used to create an energy interval. The way this button works is that it will create a parameter in whatever table was clicked last. Since here I had selected C50, then it will create a frequency parameter. And again, Odin will create a copy of the currently selected parameter, which you can then modify. However, only two types of parameter can be modified: reverberation and formula. Depending on the currently selected parameter, it may get automatically changed to reverberation or formula. And you can also change it yourself. For the reverberation type, you specify the decay range used to calculate the regression for reverberation time. You can also select whether to include the Xi parameter, which expresses nonlinearity. For the formula type, you need to type the formula down here. You can look at other parameters to get an idea of the syntax and available expressions, but you can also look at the full list of available expressions in Appendix J of our user manual. Remember that you can access the user manual from the Help menu. Let's try to define a C60 parameter with the energy interval I created earlier. You can also use other parameters as part of the formula. The only requirement is that the parameter in the formula should be above the current parameter in the list. Just as an example, here we can add C50, even if it doesn't really make sense. However, Odin will not recognize C80 in this formula, since C80 is further down the list. Let's look at the icons at the right side of the window. You can delete a parameter with this icon. However, keep in mind that T20, T30, and SPL cannot be deleted. You can also move parameters up and down the list. And you can save your current parameter list. This is so that you can load it back in your current model or any other model. However, if you save it with the file name Odion, this will become the default parameter list for any new model. You can load a saved parameter list with this icon. This icon will reload the current program default for the parameter list, so the file currently named odion.pce. And this icon will reload the factory defaults, that is, the parameter list that was originally the default when Odion was first installed. This icon allows you to load the parameter list from any other Odion model. Finally, these icons allow you to load the grid scale selections from the program folder or from another room. Here, it just means which color scale is selected for each parameter. The room acoustic parameter list is specific to each model. So, if you modify the parameter list for a specific model, it will change it for that model only. However, if you edit the parameter list without any room open, you will be editing the program default, that is, the odion.pce file, which will apply to all new models. With that, we conclude this tutorial, and we hope you have found it useful. Good luck!